Hi everyone, welcome to the Earth Science Regents Review podcast series created by Homix Middle School Earth Science Department. Today we're going to be talking about page 13 in the reference table, station models. Now, station models are a huge tool for a meteorologist because they give you a lot of information in a really small space. So in the reference table at the bottom of page 13, you actually have two station models. You have one without an explanation and one with an explanation. So any questions you get on this on your Regents, please come to page 13. So let's get started. The great thing about your station model is that all the variables are always going to be in the same spot from station model to station model with the exception of wind direction. So the first variable we're going to talk about is air temperature. That's always going to be given to you in degrees Fahrenheit, and that's going to be really in the upper left-hand portion of your station model. Below that is going to be your visibility. That's going to be given to you in miles, sometimes as a fraction, sometimes as a whole number. It's basically how far you can see. Next to that is going to be your present weather. Now, your present weather is always going to be a symbol. And those symbols can be found at the bottom of page 13, all your present weather symbols there. Okay, what's also in that section are going to be all your different types of air masses, continental Arctic, continental polar, continental tropical, maritime tropical, and then maritime polar. So all your different air masses, and they come from different source regions. Then you have your different fronts, cold, warm, stationary, and occluded, and then your hurricanes and tornado symbols as well. So a lot of information at the bottom there, but for the station models, present weather is the one you're going to really want to focus on. Below your visibility and present weather is going to be your dew point. Again, that's going to be a degree Fahrenheit value, and you notice that your air temperature and dew point are very close together in this example. It means you're going to get some precipitation soon in the form of snow. Next up is going to be your wind speed. Now, your wind speed is going to be important here because it's indicated by what we call feathers. Those little tabs that are coming off the bar coming out of the station model there are what we call feathers. Now, a big feather is 10 knots. Half a feather is going to be 5 knots. So you add them up, and in this example, you have a total of 15-knot wind. Now, a knot is just another unit that we're going to use to measure wind speed, very similar to a mile per hour. Now, here's the problem. Sometimes what will happen is sometimes you'll only have one line, and it's very hard to decipher whether it's a long feather or a short feather. If the feather is at the very, very end of the arrow, which indicates wind direction, you're going to get what's called a 10-knot wind. If that line is going to be indented any degree, that is going to be a 5-knot wind. So it's very important to know the difference between the two. Now, like I said, wind speed is also going to be associated with wind direction. Winds are named from the direction in which they come from. So this is going to be a southwest wind. So winds are going to be named from the direction in which they're going to originate from. This is a southwest wind coming from the southwest. The next variable is going to be cloud cover. Cloud cover is going to be the central circle of your station model. It's all going to be broken up, for the most part, into 25% increments. So completely clear skies would have no filling in at all. Complete overcast skies would be 100% filled in, and increments of 25 there on in. So very important to understand your cloud cover. That's going to go right along with the amount of humidity in the air. Probably one of the more common questions asked of a station model is going to be from your barometric pressure. Now, your barometric pressure on a station model is always going to be a 3-digit value. Now, there's a little rule that you need to follow in order to figure out exactly what the air pressure is going to be. So here are your rules. If your pressure value on your station model is between 000 and 499, you're going to put a 10 in front of that. If your number is between 500 and 999, you're going to put a 9 in front of your value. What you're going to do then, you're going to put a decimal in between the last two numbers. That'll give you your entire pressure from that station model. In this case, your example there is 196. That's between 000 and 499. So you're going to put a 10 in front and a decimal between the 9 and the 6. So your pressure there is 1,019.6 millibars. The next feature down is going to be your barometric trend. What has the pressure done over the last 3 hours? Is it rising? Is it falling? Is it holding steady? Well, a lot of times what will happen is there's going to be either a plus sign or a negative sign in front of those numbers. And that's going to tell you whether or not it's going to be rising or falling. So there's some barometric trend rules you need to follow. First off, you want to add a decimal in between the two numbers when you take it off the station model. A plus or a line sloping upward is an increase in pressure. A negative sign or a downward sloping line is a decrease in pressure. That's how you're going to tell whether or not the pressure has been rising or if it's been falling over the last 3 hours. The last variable is going to be your precipitation. This is the only piece of information on your station model that actually has a decimal on the station model itself. So with your precipitation, very important to be able to identify that. That's going to tell you how much has fallen over the last 6 hours. So that's it for your station model. Good luck with that, and we'll talk to you soon. Bye-bye.